Good news, everyone! You can expect to see Aurora in the vast majority of US states tonight, with estimates suggesting a figure ranging from 28 to 46 states. Assuming the latter figure is correct, this means portions of every state assuming clear skies except Hawaii, Arizona, Louisiana, and Florida. While the space weather forecast might change, the aurora is expected to be at its strongest between 6 a.m. and 9 a.m. UTC time on January 20th, 2026, which translates to these time zones in portions of the world that will be at nighttime when it happens. I'm leaving this on screen for a few seconds so you can take a screenshot or write these times down in case you want to plan or attempt to view aurora tonight, weather permitting. While this solar storm isn't expected to create the most widespread aurora in the last 20 years, it is expected to be the strongest solar storm in terms of the levels of solar radiation since October 2003. While this is of absolutely no concern to anyone on the ground since our planet's atmosphere protects us, it is expected to cause the following problems per the NOAA Space Weather Prediction Center, which I am quoting word for word here. Complete loss of high-frequency communications in polar regions, enhanced risk to space launch and satellites, high flying interests mainly along polar routes should monitor the situation. And yet, at 1938 UTC time today, a full 8 hours earlier than expected, the solar storm reached an intensity of G4 and could technically further increase. So, it is completely possible that the solar storm reaches an even higher intensity, in which case I will change the title of this video to state that aurora is visible in not 46 but 49 states. Auroras, for context, are created when highly charged particles released by the sun slam into Earth's magnetic field, which then flow down towards the magnetic poles. Once these particles reach the upper atmosphere, specifically in the thermosphere, they interact with various gas particles present, where they shed some of their energy, causing the atoms to react and release a photon, producing light. Different gases at different altitudes in the atmosphere produce different colors during this reaction, with this helpful graphic explaining the specifics. Auroras occur constantly due to our star's solar wind, but sometimes unusually energetic outbursts of material occur in what are known as a coronal mass ejection. The size and intensity of the ejection determines the strength of the resulting solar storm on Earth. In the case of a latest event, at 1809 UTC time on January 18th, Sunspot region AR 4341 created an X1.9 solar flare, the strongest of 2026, and this released a coronal mass ejection that headed towards Earth. As a whole, coronal mass ejections occur at a variable rate in an 11-year-long cycle which correlates with the flipping of the sun's magnetic poles, varying from 1 a week to 3 a day. Currently, we are in a higher than average phase of activity in this 11-year cycle, although on a decreasing trend translating to here on this chart. About 5% of observed CMEs the sun creates strike Earth, translating to a rate of at least 10 a year. Most of these create small solar storms with limited effects, being rated as a G1 or G2 on a G1 to G5 scale, which is similar to the current hurricane category scale. Tonight's storm is expected to reach a peak intensity of G4 strength. I hope that everyone can enjoy this spectacular aurora tonight. Hopefully you did not mind this non-geology science video.